who first shared their stories in caves, connected art, nature, and science, led us toward new horizons. Who thought to capture motion, spark an engine to life, turn television into a playground. Every day, you create the playful, the functional, and the unexpected. You break down walls and take us to astonishing places. Tell stories, leap borders, and create beauty for tomorrow. Because at Unity, we believe the world is a better place with more creators in it, where everyone has a chance to shape the world.
Good afternoon, everybody, and welcome to our 2021 SAPAC webinar series, coming to you today from all of us from Singapore today. Just let me share my screen and we can get started. So our region in South APAC covers quite a diverse area from India and surrounding countries, Southeast Asia and Australia, New Zealand. We're here with you live every week at this time. Welcome to our YouTube viewer audience also today who are joining us. Just some tips for today's interaction, today's webinar. Please don't use the chat for any questions. We just use the chat on Zoom to post links and any comments we may have about audiovisual quality. All questions should be placed in the Q&A box, and we do not use the raise hand function for this webinar. Coming soon, we're going to be giving away a lucky prize draw of some Unity swag for attendees of the live session. So these people who have registered via email or via a link on social media and are attending via Zoom. Look out for that very shortly. Some technical difficulties today. And our October webinar schedule, we've got one more left this month, but today we're doing Introduction to Augmented Reality. And next Friday, please join us for Basic Foundations for Multiplayer Games. And with that, over to you, Yifei, with today's session.
Thanks, Andy. Hi, everyone. Thanks for joining me in today's webinar, Introduction to Augmented Reality. Today, we will look at what is augmented reality, what are some of the use cases of AR, what's the market size of AR, how does AR work, what is ARFoundation, and what's next after today's introduction. So AR really falls under the umbrella of XR, or extended reality. And this includes AR, virtual reality, VR, and mixed reality, MR. So AR, as the name implies, augments the reality that we perceive and let us see things that don't exist in the real world, likely through the lens of a phone camera. VR, on the other hand, completely immerse the user in a virtual world. And MR, coined by Microsoft to differentiate between what the HoloLens offers and what AR offers in general. But the main difference is MR mixes the virtual world with the real world. So what can we do with AR? The obvious example here is Pokemon Go. I'm sure everyone has played Pokemon Go even to today. And in e-commerce, like the IKEA Place app, to better experience and visualize the product before making the purchase. This is especially useful in the COVID world, where you can't always visit a physical store. Another example, this is Res AR, a company that we acquired recently. This shows how we can use AR to try on virtual shoes. And using computer vision in AR, you can track more than just your feet. We can track faces and augment your faces. Art exhibition can come to life and offer a different experience than just a static image. And here's an example of how Coca-Cola uses AR. It is not just all fun and games. AR is essential in the industrial applications too. AR can be an effective tool in self-led training. Here we can see through AR, users can identify different parts of a machine, and using AR to assist in assembling parts and troubleshoot or perform maintenance on the machine. It can be essential in examining and validating design before construction begins. This allows an engineer to detect flaws or problems early and to avoid very expensive rework later on. So how big is AR? Here's a report by Technovio, and Technovio forecasted the AR market to grow by 77 billion from 2020 to 2024. If you want to read more about the report, you can scan the QR code here. And another report by Markets and Markets echoes the similar sentiment. And here's the QR code if you want to read more about the report. So Apple's Tim Cook is no stranger to AR, and he has been very bullish on the future of AR. He shared how AR can be bigger than VR back in 2016. And as recent as 2020, he shared his excitement for AR again. So how does AR work? Say you have a picture taken with a camera and you want to add a red cube on the table. You will need to draw a virtual red cube against a transparent background like so. And you would overlay the image of a red cube on top of the picture taken with a camera. And if the red cube lines up just right, it will look like the red cube is sitting on top of the table in the real world. To create the illusion that the red cube sits on top of the table, the pose of the virtual camera has to match the real world's camera. So for example, you see here the real world camera is positioned to the right of the table and aimed at roughly the middle of the table. In the virtual world, the virtual camera's pose will need to match the real world's camera. So the spatial relation between the virtual red cube and the real world camera can create the illusion that the red cube is planted in the real world. Since the virtual cube is overlaid on top of the picture, the cube is always in front of everything in the picture. So this can create some problems. So for example, in this picture here, we can see that these drums here is in front of the person on the left, but the person on the right is obviously nearer to the camera, but he appears to be at the back of the drums as well. So this breaks the illusion of AR. So fortunately, new techniques and machine learning helps to minimize this problem. Here you can see the person can move in front of and between virtual objects, all thanks to the ability to recognize and segment humans from the video feed. As you saw from the previous slide, AR works with video feed and not just a static image. This means that we will need to track and estimate the real-world camera's pose, so the virtual camera will be able to mimic its pose. So there are many ways to track the real-world camera, but for mobile AR, we commonly see the use of QR markers or image targets. These markers have a known size and dimension, and through computer vision, we can estimate the real-world camera's pose. Another technique used is SLAM, or short for simultaneous localization and mapping. This technique relies on recognizing unique feature points in an image, and coupled with sensors on the device like accelerometer, gyroscope, we can quite accurately estimate the camera's pose without relying on markers. Typically, the video feed is analyzed in grayscale, and a computer vision model will try to pick up points with high contrast. And by identifying the unique feature points, we can then estimate the camera's pose as the camera moves through space. This is also the reason why SLAM doesn't work well in an environment with mainly just clean walls or floors or reflective surfaces, because it is difficult to pick out unique feature points, or there aren't enough feature points for the camera to estimate its pose. So while we don't need to know the details of how AR works, having this knowledge gives us a better idea on how to plan for a good AR experience. If you want to build AR experiences for the mobile phone, most likely you would rely on Apple's ARKit or Google's AR Core as the AR SDK. These two SDKs offer similar features, but they use different API. This means if you want to target both iOS and Android devices, you will need to develop twice, once with ARKit and again with AR Core. So fortunately, you can rely on ARFoundation to develop your AR experience once and deploy to both iOS and Android. ARFoundation is really an abstraction layer, so you can develop in Unity with ARFoundation's API without having to worry about all the different AR SDKs such as ARKit, AR Core, Lumin SDK for the Magic Leap, or Windows 10 SDK for HoloLens. Here's a quick glance at the features supported by ARFoundation. All right, let's jump into a quick demo to show you how you can get started with creating a simple AR experience. I'll be showing you how you can get your project configured and how to set up your universal render pipeline projects for AR development with ARFoundation. So the easiest way to create a AR project is through the Unity Hub and selecting the AR project template. So I'm going to create a project now with the AR template. Okay, so now that the project is created, I'm going to close this dialog box here. I'll close the tutorial panel as well. Okay. First thing I would check is the package manager. And make sure that we have ARFoundation package installed. So yes, we do have the ARFoundation package installed, along with the AR Core and ARKit XR plugins. Next, I want to select my target platform. So my phone is running Android, so I'm going to switch to the Android platform. And that's done. And of course, you can switch to the iOS platform if you are targeting iOS devices. Next, I would want to go to the project settings and look at the XR plugin management tab here. And for the Android, because I'm targeting Android, so you will want to check AR Core plugin to enable it. All right, cool. And select the AR Core and just make sure that I would want this to be required, that required as well. All right, cool. So let's create our first AR experience. So the project template has created a sample scene for us. And in this sample scene, we have all the necessary components to get started. So there is a directional light and a AR session game object. And this AR session game object has the AR session component and AR input manager component attached. And the AR session origin game object has the AR session origin game component, the AR play manager component, AR anchor manager component, AR raycast manager component, and a anchor creator component. And underneath it is the camera. So the camera is here, and this is what's rendering our AR object. And with it comes the AR camera manager component and the AR camera background component. All right. So we will try to create the simplest AR experience without any coding. So I prepared a image target for us to track and create our AR object once we've recognized the image target. So I'm going to import a image that I've taken of my daughter's storybook cover page. So I'm going to create a folder. I'll call this image target and import the image. Okay, so the image looks like this. It is from a cover of a children's storybook. All right. Next, I would also want to create, in the session origin, attach a component, AR image target manager, tracked image manager, AR tracked image manager. And here we see the AR tracked image manager is expecting a serialized library and the tracked image prefab. So we will need to create a serialized library. So in the same folder here, I'm going to create an XR reference image library. Okay, and in this reference image library, we can add all the images that we want it to recognize. So I'm going to add one image, and on my storybook cover will be the image here. We can specify a size if you know the physical size of the image target. So for this is 0.17 and 0.17, and I want to keep this at runtime. Okay, and back in my session origin and AR track image manager, I'm going to assign this to the slot here. And I want to limit the maximum number of moving targets to 1 for now. And this is the game object that we want to spawn as soon as we recognize the image target. So for this, I'm going to import some asset to my project. Okay, so I'm going to import this whole folder here. Okay, that's done. So I'm going to create a prefab from this 3D model that I've downloaded from Sketchfab. It looks like this. Cool. Just to make sure I have a good size, I'm comparing it to a box here. This looks good. All right, time to make this into a prefab. Let's call this Sweet Guy. Right. And make this into a prefab. And I will assign that prefab to this slot here. So now, as soon as we recognize our image, which is the cover of a storybook, the squid guy will appear. All right. So I'm going to save this scene. Go to my build settings, add this scene to my build, and I'll start building. Build and demo. Save. So I have the book here with the cover, and there you go. As soon as it recognizes the image, we see our squid guy. Pretty cool. So what if you want to use Universal Render Pipeline for your AR project instead? So here, I'm gonna go to Unity Hub and use the Universal Render Pipeline template and create a project. All right, let's create my project. Okay, cool. Now I have the project created. And just like before, I will switch my target platform to Android. And again, switch to iOS if you are targeting iOS devices. Okay, so once that's done, go to Package Manager. And make sure you are viewing the Unity registry and install ARFoundation here. So I'm going to install ARFoundation now. Cool. Once that's done, I will go to project settings and again XR plugin management and check AR Core for Android. So this will automatically install the AR Core plugin for us. So if you look at Package Manager again, now we see AR Core XR plugin is now installed. So just check required. That's cool. Next, we want to go to player settings and remove Vulkan from graphics API because ARFoundation doesn't support Vulkan. Okay, and to run AR Core, we would need a API level of at least 24. Okay, so with these out of the way, it's one more thing we need to do. So in the project settings, let's check out our graphics. So we're using the Universal Render Pipeline, and we're using the high quality settings. So high quality, so that's this guy. And we are using the forward renderer render data. So that's here. So this is a very important step. We will need to add a renderer feature to our forward renderer. And we need to add the AR background renderer feature. So this will allow the video feed to come through as a background in our screen. Otherwise, when you start the application, you will just see a black screen. So this is very important. And with that, if you look at the sample scene here, let's create a new blank scene. Don't save. All right, cool. So what we need is a AR session. So game object XR and create an AR session. And we also need a AR session origin. And in the AR session origin, there'll be an AR camera created for us. So we don't need the main camera in the scene anymore. And in the AR session, we have these two components. AR session origin, that's only the AR session origin component. So if you want to recreate what we've done with the built-in render pipeline, you will need to add the raycast plane manager and the raycast manager as well. And of course, if you want to track image targets, we will need to add AR tracked image manager as well. And there you have it. So what we've done so far, it's very basic and can still look artificial and doesn't blend well with the real world. So let's take a look at some features or technique we can use to create a more immersive AR experience. So the image on the left, we can see our guy here doesn't cast any shadow, but the image on the right, our guy do cast or gives out hint of some shadow casted onto the storybook. And not only that, we can also use light estimation to estimate where the strongest light source is and blend the virtual light with the real world light source. So the image of on the left, you can see it kind of suggests that the light source is coming from the right and shining on our character, as you can see from the shadow casted by the character's head onto the body. But the image on the right has a better match with the environment light source. So here we see it's giving a suggestion that the light source is coming from the left instead of the right, and is you can as evident by the shadow casted by the head onto the body. We can also use environment probes to let the AR object reflect off the real world. So if you look at the image on the left, it is just reflecting off the default Unity skybox. You can see the outline of the statue here. There is some hint of blue, and on the chest area of the statue, it's also giving out some hint of blue. But the image on the right here has a more accurate, a better blend with the environment because it is reflecting off the real world. And finally, we can also add depth or human occlusion, so the object looks like it is planted onto the real world. Here, the virtual cat on the left looks out of place and is breaking the illusion, the AR illusion, because it is in front of the furry sofa where it's supposed to be partly occluded by it. And the image on the right here is a better representation because now we see the virtual cat is being occluded, partly occluded by the furry sofa. So let's jump into our demo here and I'll show you how we can use these 4 techniques, like estimation, environment probes, depth occlusion, and adding shadows with ARFoundation. Now let's see how we can add some features to better blend our AR object with the world. So what we have previously was our guy here without any shadows. So I'm going to use a blob shadow, and it's just a simple plane underneath my character here. And I'll be using a texture for the shadow. So perhaps something like this, 0.5, 0.5, 0.5. There we go. And I'm going to import a texture here that I can use. Okay, and the texture looks something like this. Like this. So I will create a material, shadow blob. Okay, and change this to fade and assign my blob shadow texture here. And I'm going to set my smoothness all the way to 0 and give it a little tint like so. some transparency like so. Okay, this is probably still a little bit too big. I'm gonna scale this down a little bit more. 0.25. There you go. All right, roughly something that looks like that. All right, cool. And I'm gonna add this shadow block to my prefab here and apply my settings, and there you go. So I have my guy here with a plane and a texture applied that has transparent texture that looks like a blob shadow applied here, just to give it a hint that there is this guy is casting shadow onto whatever surface we place this guy on. Next, what we want to do is also enable light estimation. So on the AR camera, you want to turn on light estimation. So I'm going to just turn on everything, but you can enable individual light estimation features, but I'll just, for the sake of simplicity, I'm going to enable everything. All right. And this isn't enough to have light estimation working. We will need a simple script to take advantage of the data that comes in from light estimation and apply it to our directional light here in our scene. So fortunately for us, there is a ARFoundation sample project that we can take advantage of. So if you go to this URL here, we have the ARFoundation samples GitHub page, and there's a tons of samples here we can use as reference, but the one I'm interested in is in the scripts here. There's a basic light estimation script. There is also a HDR light estimation script. So I'm going to use this one here and import to my project. Okay, so I've downloaded the script and going to drag and drop to my project here. And once you have this script, you can add to your directional light here. And it is expecting a camera manager. So I'm going to just drag my camera here. And that's it for light estimation. But let's take a look at the script here and see what it does. Okay, so not to dive in too deep here, but just a quick glance and see what this is doing. So we see that we have a reference to the AR camera manager, and we are subscribing to the frame receive event. And in the frame change function, when we're handling this event, we are getting the information from the light estimation. So we get things like the average brightness, we get information like the average color temperature, color correction, the light direction, the intensity and the color. And we can apply these values to our light. So for example, here, our light color, and we apply it to our light's color. And the intensity value here, we apply it to our light's intensity, and so on. Cool. So let's go back to our project. What next? We can also look at how to add, let our character or our AR object reflect off the real world. So I'm going to add in my AR camera game object here, an AR environment probe manager. Environment probe here. Cool. And that's it. And lastly, we can also look at adding a AR occlusion manager here. And this AR occlusion manager will allow us to have depth occlusion or even human segmentation occlusion. So because I'm using an Android phone, these features are only available on iOS devices, so it's not going to work for me. I'll just use the depth occlusion, and I'm going to choose best quality here. Okay, cool. Let's just save this and make a build. Okay, cool. So I've made the build and I've copied to my phone. So let's take a look at and see how it looks like right now. So just like before, it recognizes the image target and we see our squid guy. And this time we can see the blob shadow underneath our character here. And also it's estimating the light source where it is coming from. And it blends better with the environment. So to better visualize the environment probe, how it works, I'm going to use another asset because our squid guy is not very reflective, so it's not very obvious the effect. So I'm going to import a golden statue instead. So this should give us a better visualization of how the reflection works. Okay, cool. So the statue looks like this. All right, I'm going to apply the same blob shadow material on here. Okay. Right. And for this one, I will plant this AR object onto a surface that I've tapped on. So again, I'm going to rely on the sample here, the ARFoundation sample GitHub project. There is a script here that we can use for exactly that, and it is called place on plane. So what's going to happen is with this script, once the AR application recognizes planes or surfaces in your environment, you can tap on those planes to place your AR object. So I've imported the place on plane script to my project, and I will just attach it to my AR session origin game object. Place on plane. And here it is expecting a place prefab. So the moment you tap on a plane or surface, this object will be instantiated or placed onto where you've tapped. So I'm going to place my golden statue prefab here and save and make a build. So I've built and copied the application to my phone, and let's see how this looks like. So you can see these dots here. They indicate planes that the application found. And I can tap on these planes here to place my object. And we can see this statue here is looking pretty good. It's reflecting off our real world. But let's do a comparison to see how it looks like without the environment probe. Okay, so again, I've copied and installed the application to my phone, and this time we will try to place the object here, and there is an environment probe effect on this statue. So it is just reflecting off the Unity skybox, is not reflecting off the real world environment here. And finally, let's take a look at the depth occlusion feature working. So I'm going to place my statue over here. Right. And as I move my phone, and this little table here will occlude my statue. Awesome. So we've seen how we can easily create a basic AR experience with image target and how we can place AR objects in the real world. We've also seen some features we can use to better blend the AR objects with the real world. This is just the tip of the iceberg, and I would like to encourage you to check out the ARFoundation sample and demos, as well as Unity-Mars. You can find the links to the ARFoundation samples and demos here, or you can scan the QR code. This will take you to the demos GitHub page, and the demos GitHub page also includes a link to the samples GitHub page. Here you will find a lot of very cool demos and how you can use ARFoundation's features. Unity-Mars is a AR creation suite. It lets you easily create and simulate AR experiences within Unity. Let's take a quick look at the video here.
What's Unity-Mars? Well, certainly not the planet, but it really knows this world. Unity-Mars gives you everything you need to create powerful mixed and augmented reality experiences that interact intelligently with the real world at any location and with any type of data. Need to visualize a place or product, create a unique experience for an event, train up your staff? No problem. Imagine the possibilities as you author for games, sales, marketing, and more for any device or hardware platform. With Unity-Mars, you can quickly capture and assemble real-world assets like locations, objects, and props. Then, just drag and drop them and test on the fly, all without leaving the Unity editor. Unity-Mars experiences are powerful, interactive, and intelligent. Build once and deploy on any AR-enabled device. Get Unity-Mars now and shape the world.
So Unity-Mars comes with some very powerful features. It's able to recognize different surfaces. So say, for example, it's able to differentiate a tabletop and a couch or the floor. And based on the different surfaces, it's able to intelligently place your AR objects. So say, for example, if you want to visualize a robot vacuum cleaner, it doesn't make sense, or it doesn't make a lot of sense to see the robot vacuum cleaner on the table or on the sofa. It will make more sense to see it on the floor. So with Mars, you're able to create AR experiences that intelligently identifies surfaces and place your AR objects onto those surfaces correctly. And on top of that, you are able to simulate different environments to test out your AR experiences. So you don't have to be on site to test your AR experiences. So let's say you have an AR experience that targets a concert hall, and you may not always have access to different concert halls around the world, but you can simulate how your AR experiences will work in a virtual concert hall within Unity with Unity-Mars. So thank you for joining me today. Again, my name is Yifei. I'm the head of field engineering for South APAC. And if you would like to reach out to me, my email is yifei@unity3d.com. And if you want more information about ARFoundation, here's a link to the ARFoundation page on the Unity website. And let's open up the time for Q&A.
And just while you're looking for those Q&A questions, please take the time to fill out our survey form. That just helps us to measure the quality and understand what content our audience would like to bring to you every Friday at midday, Singapore time. And over to you for more questions.
Thanks, Andy. So let's take a look at the Q&A. So there's a question here. It says, which one is good for final product, AR Core or Vuforia? So really, it depends on the application that you're building and the the platform or devices that you're targeting. So AR Core is obviously widely supported on Android phones, but you don't just run AR experiences on phones. Sometimes you may require to run AR experiences on headsets, for example, HoloLens or Magic Leap. And for these devices, they don't support AR Core. So Vuforia will be a better fit for those devices, headsets, AR headsets. So yeah, really depends on what applications you're building and what are devices that you are looking to support. Another question here. If possible, can you regarding video? I'm not sure what is the question here. If possible, can you regarding video? Are you perhaps asking whether we can share the video recording? If that's the question, then we do send out the recording for this webinar next week to all registered attendees. There's another question here. Any plugin to support develop in Unity and deploy on browsers? So if you're wondering, or if you're talking about web AR, so there isn't official support for web AR at the moment, because we do still consider web AR as experimental. So as web AR becomes more widely supported, then we will definitely support web AR, but not at the moment. But that's not to say there aren't any third-party web AR support. So you can look into some third-party support for web AR and build it with Unity. There's another question. So could you please give a brief roadmap for AR and MR, please? Well, this is probably like another topic for a webinar, or but if you would like to check out our roadmap, we have our roadmaps on the Unity website, and you can check out our roadmaps for not just AR and MR, but all features of Unity, and that means including AR and MR. Another question here, I would 3D scanning human, but how to import to Unity, which format support? So I'm guessing you're saying you have scanned a human as a 3D model, and you are asking how to import that 3D model to Unity and which format is supported. So if I'm interpreting your question correctly, it depends on the format that you have scanned the human or the person. Most likely it is in one of the 3D formats that is supported by Unity. If it is not, say for example, it might be a STL format and is not natively supported in Unity, you can look into Pixie. It is a standalone software, and you can use Pixie to convert that format STL to FBX, which is more widely supported as a real-time 3D file format. So hope that answers your question. Okay, so I guess we'll just wait a couple more minutes to see if there are other questions. There's another question here. We can use POS Pro in URP in AR2. I'm not sure what POS here means. PO Pro in URP.
Saying Post Pro, is what he's saying.
Post, yeah, I'm not sure what Post Pro.
Is it post-processing?
Oh, post-processing? Okay. Okay, so I guess the question here is, can we use post-processing in URP in AR? So yes, answer is yes, but I would definitely test and experiment on a different post-processing, because you are running AR experiences on the mobile phone, and post-processing tends to be expensive depending on which post-processing effect you're using. So in general, yes, you can use post-processing in URP in AR, but do experiment and profile to see if that post-processing works for you. There's another question. Would you prefer Vuforia for developing AR applications? So this is similar to another question asked earlier. So it really depends on the AR application that you're building and the devices that you're targeting. So V4AI has the advantage of it's just like ARFoundation. It is able to run on both iOS and Android devices. Plus, it is able to run on AR headsets as well, say the HoloLens or Magic Leap. So, but it is missing some of the features that ARKit and ARCore offers. So, for example, you don't get light estimation or the environment probes or the depth occlusion, all those nice features. But what you get in what you do get with V4AI is the support on a wider range of devices. And sometimes you would need V4AI to instead of ARCore or ARKit, for example, if you're targeting AR on headsets like the HoloLens or Magic Leap. So yeah, again, really depends on the experiences that you're building and the devices that you're targeting. Another question here. As Unity Mars gives us access for 45 days, after that, can we use emulator from Android Studio for simulation? So yes, you can use emulator from Android Studio for simulation, but if you're talking about building for AR, you can't rely on the simulation, I mean the emulator alone to simulate AR because you do require a video feed for ARCore or ARKit to process the tracking and plane detection. So yeah, the emulator doesn't give you that. So you don't have a way to test your AR application using the emulator alone from Android Studio.
Okay, that looks like all of the Q&A. Thank you very much for joining us today as we come to you every Friday, and look forward to seeing you next week. Any further questions you may have, please email them to the SAPAC email. If you scroll in your chat screen to the links at the top, you'll see our email address there. And also just a reminder, if you could please complete the survey form. The link is posted also in the chat window. It'd be great to have your feedback. Oh, there's one more question just popped in.
Okay, one more question about image target in ARFoundation. Our experience is not stable for object because I worked before. It's very good for this AR image target. Any settings you must do for get better result AR image target? So the question is asking for what's the best settings or best practices to get good tracking, image target tracking with ARFoundation. So so it is true that I do notice there's a difference in quality of tracking on ARCore versus ARKit. So ARFoundation, like I mentioned, it is just an abstraction layer. Underneath it is relying on the system's AR SDKs. So if you are running on an Android phone, it is going to rely on ARCore for the tracking. Likewise, if you're running it on an iOS device, it is going to rely on ARKit. So ARFoundation itself doesn't handle the image tracking. It is relying on ARKit or ARCore for the tracking. So the difference in tracking depends on the SDK. So I myself do see that the ARCore's image tracking is not as stable compared to V4AI or ARKit. So I think that is the limitation of the AR SDK itself, not so much the image target quality, but there are you do need to take note of the image that you're using for tracking though. It needs to have good feature points on the image target, so it has enough information to latch on and have a stable tracking. But again, if you're just comparing in general, I do find ARCore has a less stable tracking than compared with say V4AI or ARKit. Could you please do one example demo in multiple image targets in ARFoundation next time? Sure, yeah. You can also check out the ARFoundation samples or ARFoundation demos GitHub page. I believe there is an example there that shows how you can have multiple image target in ARFoundation.
Excellent. Thank you, everyone. Thank you, Adam, coming to us from Australia, Ife, Jenny, Sarah, myself, Singapore.